This is the time graph correlation between ecological indicators that we're using in our equity metric methodology. So we've used three ecological indicators that you see here in our StatPlanet interactive maps and graphs, and they are biocapacity per capita, which shows the access to natural resources, which is one of the primigenial inequities, the distribution of borders in the world, and how some countries are left with limited resources, others with vast resources. The carbon emissions as the probably most urgent planetary boundary that we're trespassing and putting at risk the coming generation with a huge inequity burden and excess mortality this year, and the ecological footprint, which tries to put together, this is an indicator estimated by the Ecological Footprint Network, tries to put together all the ways in which we're using natural resources and whether we are trespassing the natural recycling capacity. So you see how biocapacity, as you saw in the time map, has evolved over time, and it's quite heterogeneous with a high biocapacity in the Americas until the end of the century, where they start being reduced. Also in the northern countries, less populated, less densely populated. Also in Oceania, and lower biocapacity in Africa, especially as population growth has increased in Asia and particularly India, North Africa because of their ecological conditions, China, and gradually reducing in Europe because of their ecological footprint and also because of their highly densely populated region. So this is biocapacity. Let's look at the ecological indicator of carbon emissions. Carbon emissions really have been concentrated in the high-income countries, so what we call industrialized countries from the Industrial Revolution, North America, Europe, Russia, Japan, Canada, New Zealand, and they have also increased in Southern Africa, in the oil-producing countries in the Middle East and North Africa, in the Southern Cone with its growing GDP of South America, its growing GDP per capita, Malaysia, etc. So it has a very, very high correlation with the use of economic resources, really. We will see that as well. And the other ecological indicator, which is the ecological footprint, is very similar to carbon emissions. You will see how it also concentrates in the high-income countries, probably with some slight differences, like a higher ecological footprint in China, even than its carbon emissions, and higher as well in most of South America and Mexico, Brazil, and also in Southern Africa as before, North Africa, Middle East. There's also a high correlation, but we will see this better in the correlation graph, where we will look at the three of them and see how they correlate one another. And you see here the relation of biocapacity, which is let's say how countries are endowed because of their arbitrary divisions with ecological resources, and how do they use them in terms of ecological footprint. Is it the case? Let's start with looking at them with a unequal bubble size. Would it be the case, the hypothesis, that countries with more ecological resources, more natural resources, use them with less care and in a greater rate? Well, we see that this has changed. The correlation line is very, very, very slightly positive and with very low degree of correlation. Yes, there's a tendency to see countries, particularly here with higher biocapacity, if we exclude these very high biocapacity countries, Guyana and Suriname, basically huge forests with very limited population. But if we look it up here, and probably with a greater focus, we can do it this way. There is somehow a correlation of greater biocapacity, greater use of those resources in terms of ecological footprint, but with a huge deviation. Particularly countries here in orange have, mild, moderate levels of biocapacity per capita because of their population density, and they use it highly because of their consumption patterns and their high GDP. And so these countries, the higher the GDP, the higher the ecological footprint, and regardless of their biocapacity per capita. While countries in blue, basically African countries, with the same level of biocapacity, they have lower biocapacity and ecological footprint, as some other countries here in America, although more evenly distributed. And what really influences this correlation is as you will see, the GDP per capita. For the same biocapacity, the countries that have higher ecological footprint are those that have here a greater GDP per capita. So almost like hot air, GDP per capita brings up the ecological footprint. Now let's look at the correlation between the biocapacity per capita and the carbon emissions. And the carbon emissions here are, of course, as in relation with ecological footprint, the higher the biocapacity, it seems the higher use, the higher level of carbon emissions. Although let's put this, yes, it's still limited by 20 and exclude those very high countries with very high levels of biocapacity. But you see here countries that have greater carbon emissions than one would expect due to their carbon emissions, and these are countries with large oil producing economies. You see there Oman, Saudi Arabia, Bahrain, which others create, Qatar. They have very high CO2 emissions, in fact with limiting biocapacity. They use their resources really under the ground to boost their economies. And again here other oil producing countries like Iraq, Iran, etc. While also again the countries with high GDP are up here with high levels of carbon emissions regardless of the biocapacity level, with very low levels of carbon emissions those with low GDP regardless of the biocapacity. So in a way, and you will see it here, it's similar than in the correlation between biocapacity and carbon footprint, that it's much influenced by the GDP constant value, and here the higher let's look at it in a lower scale so we can see it better. The higher the GDP, and here this depicted with the bubble size, the higher the carbon emissions regardless of their biocapacity level. So this is the correlation between these variables. We can see, for instance, if we plot the three of them by the biocapacity with the carbon emissions and the let's put biocapacity in the bubble side, and let's put carbon emissions and ecological footprint here. We know that the maximum ecological footprint to allow natural recycling capacity is now in 2008 in the region of 1.6. It was 3 in year 1960, And we know that the ethical threshold, we call it, of carbon emissions, which if generalized, they would be, we wouldn't reach the 1.5 degree global warming above the pre-industrial level, so around here. So these are the countries that are ecologically sustainable and that we use in our model. And we, of course, choose from within them the those that are economically replicable and those that are healthy. And you see them here, and of course those that have a biocapacity lower than the world average at this point, 1.7 as well, so around this bubble size. So we could see countries of the kind of Morocco, Kyrgyzstan, Cape Verde, Syria, India, such a large country with a low biocapacity and low. But mind you, the level is just surpassing the level of carbon emissions now in India. It won't be sustainable in that respect very soon. North Korea, the Philippines, Pakistan. Congo would be, but has a very high capacity, which is not globally replicable. Tajikistan, Cambodia, and these others. And we see here Sao Tome, Sao Principe, Swaziland, Ghana, and basically Southern African countries. And then we see here some Asian countries like Bangladesh, here also Eritrea, Mozambique, and here we are with Kenya, Liberia, Madagascar. So these are the countries which are ecologically sustainable. And we would need to choose from here, and we've seen it before, the correlation between those and those with a good level of health. And let's look here for our model country, Sri Lanka. There you are, Sri Lanka, the country which has low carbon emissions, low carbon footprint, low biocapacity, very good health, and economically replicable, constantly from 1960 till 2020.